What's going on, Linear Algebra Bros? It's Mr. C here, and in this video I just want to let you know that it is hip to be square. A square matrix, that is, because that's exactly what we're going to define. A matrix that has the same number of rows as it does columns, okay? So the same number of rows as it does columns is called a square matrix. All right, and at the bottom of the screen there is an example of a square matrix, just in kind of a generic format. And a square matrix, as you'll learn before too long, is one of the most important kinds of matrices that we work with in linear algebra. Now, in general, if we're referring to a square matrix and we're defining it generically, we'll typically denote the size by an n by n. All right? So just know that when we have explicit square matrices, we might have something like a 2 by 2, a 3 by 3, a 4 by 4. So as long as the number of rows is equal to the number of columns, we have a square matrix. One important item in a square matrix is known as the main diagonal. Now, the main diagonal consists of all the entries that have the subscript I equaling the subscript j. In other words, and actually I'll just go ahead and highlight the entries along the main diagonal. We have a sub 1, 1, that's an entry along the main diagonal. A sub 2, 2, there would be an a sub 3, 3, so on and so forth until we get to this bottom right corner entry a sub n n. So in other words, this part of the matrix consisting of all the entries that have matching subscripts is known as the main diagonal. One way to denote a main diagonal entry in general is to say a sub ij, where I is equal to j. All right, so that is it for this video. Hope you found that to be an awesome definition there. Of course, if you have any questions, feel free to let me know. Otherwise, I will see you in the next one. And don't forget, it's hip to be square. A square matrix, that is. Take care, guys.